Hello and welcome. In this submodule, I will introduce you to the various quantum network simulators. In particular, I will introduce you to NetSquid, SquidAsm, QNE-ADK, QNE-CAL and NetQASM, and give you an overview how they relate and differ from each other. First, let us start by looking at NetSquid. NetSquid is a discrete event simulator that can be used to model quantum hardware. Discrete event simulation means that future events are scheduled on a timeline and the simulation engine repeatedly moves the time and triggers the next event. This discrete event simulator is combined with a built-in qubit simulation and components for a quantum internet, such as classical ports, quantum memories and many more. This makes NetSquid ideal for creating hardware models and setting up a quantum network. Yet, for the purposes of application simulation, NetSquid remains in the background as a simulation engine and as a toolbox for creating new hardware models. This is because applications interact with a software layer that is built on top of the hardware. Emulating this software layer is done in the next simulator, SquidAsm. SquidAsm is a simulator based on NetSquid, simulating both the software and hardware of a quantum internet. Users can write quantum network applications that closely resemble those running on real hardware and then simulate them. SquidAsm comes with various advanced hardware models from researchers in the field. It also has a user-friendly modular network builder, allowing users to easily set up a working quantum network and test their applications. Next, we have QNE-ADK. The QNE application development kit, like SquidAsm, allows for easy creation and simulation of applications. QNE-ADK uses SquidAsm to simulate the execution of quantum applications. This makes QNE-ADK and SquidAsm very similar in capabilities and style. But there are slight differences in how to write applications between them. We recommend those starting out to use QNE-ADK, as QNE-ADK abstracts away some complexity and makes it easier to start writing your applications. One difference is that in the future, QNE-ADK will have multiple backends and users will be able to execute quantum applications either using the SquidAsm simulator or on actual hardware. Another large advantage of QNE-ADK is that its integration with QNE-CAL, the QNE Community Application Library. But we will discuss this in a separate section later. For more experienced developers who want more control over their applications and the quantum network, SquidAsm is the better choice. SquidAsm has implemented certain adjustments to the application writing style, addressing an issue that affects the timing of events. Additionally, SquidAsm offers a wider selection of models and network components, allowing for more advanced networks. NetQASM is an instruction architecture set. Think of it as a language, which one can use to describe a quantum application. Both SquidAsm and QNE-ADK execute applications written in NetQASM. The NetQASM package consists of multiple components. The first part is the NetQASM language. This is an assembly-like language containing detailed instructions intended for a machine. The second part is the NetQASM SDK. This is what a user will interact with when they are writing an application. The NetQASM SDK provides a way to write an application in Python in a human-friendly way. Using the compilers that are also located in the NetQASM package, the application written in Python will be converted into the NetQASM language that can then be executed or simulated. Most of these details are hidden from an application developer and they only need to learn the NetQASM SDK. That is then used for both SquidAsm and QNE-ADK. For the last part of the diagram, we will discuss QNE-CAL. The CAL stands for Community Application Library. This is an online library of user-created applications that can be found on the QNE website. This online platform allows others to view these applications and directly run them from the website. QNE-CAL is integrated with QNE-ADK and supports easy downloading of existing applications to your local machine and uploading these applications that you have created yourself. In submodule 3.3 of this course, we will explain how to download from QNE-CAL. and in submodule 3.4, how to upload. Now, let us recap and give a brief overview of the various simulators and software. NetSquid is the underlying simulation engine for all other simulators here. SquidAsm is a quantum internet application simulator that has the most advanced capabilities for simulation, making it our recommendation for advanced users. QNE ADK is also a quantum internet application simulator, almost identical to SquidAsm. It will, in the future, allow users to also run on hardware as it and is integrated with QNE CAL. Netqasm is the language for writing quantum internet applications that a user will be using both in SquidAsm and QNE ADK. QNE CAL is a public library for quantum internet applications that also supports the public running the available applications directly from the website.